Okay, so parallel and perpendicular, not too bad. Another application is quadrilaterals. So quadrilateral is any polygon that is made up of 4 sides. And what you need to know is you need to know how many different types of quadrilaterals actually exist and what are their categories. So let's start off with the most basic, which is the quadrilateral. What's important about a quadrilateral? It has 4 sides. What other things does it have? Absolutely nothing. Now, what I'm going to do is I'm going to split this into 2 different categories. I'm going to have lengths on this side, and I'm going to have parallel and perpendicular on this side. And that is huge. It tells you that parallel, what you're going to find is that let's go through. So the next category that I'm going to go for a quadrilateral is going to be the kite. On a kite, it says that that we're going to have adjacent sides that are going to be of equal length to one another. But so when I take a look, a kite says something that says this pair of sides are congruent, and these pairs of sides are congruent. That's the only thing that's special about a kite. There is absolutely nothing else special about it. On the opposite side, we're going to have the trapezoid. And just real quick, a trapezoid, there is something called an isosceles trapezoid. I don't know if they're going to include it. I will not. But in a trapezoid, what winds up happening is we wind up getting one set of opposite sides that happen to be parallel to one another. So that's a kite versus a trapezoid. From trapezoid, we move down to parallelogram. The parallelogram is specifically any shape where opposite sides are parallel. So in this case, we're going to have a situation like this, where these 2 sides are parallel and the opposite sides are parallel. And the parallelogram is where things start getting kind of interesting. So the parallelogram is going to lead to a pretty big split. One of them is our ever famous rectangle. And the rectangle is cool because this is one of the only ones where perpendicular gets used. See, a rectangle says that we have matching opposite sides, parallel opposite sides, and that adjacent sides intersect at 90-degree angles. But you never thought a rectangle would look so weird. Opposite of that, the rhombus. Rhombus is similar to the kite in that opposite sides do by nature have to be parallel. But more importantly, every single side is the same exact length. This all finishes off with the ultimate and most amazing quadrilateral of all, the square. No, not a square. Squid, a square. Freshman. The square, much like the rectangle, has to have perpendicular corners. And much like the rhombus must have equal sides on all sides. And by nature, because these 2 sides are equal, those are going to have to be parallel. And we wind up with parallel opposite sides, equivalent sides, and 90-degree angles across the board. Knowing the relationships to these makes it really easy to decide what type of shape I create. So, an example problem that they could give us is they could say that we have a quadrilateral that has the following vertices. It has vertex A, which is going to be -3, 4. It has vertex B coming in at 8, 8. We have vertex C at 10, 0. And we have vertex D at a whopping 21, 4. And the question is, what quadrilateral did I just make? This is a crazy question. There's a lot of stuff to think about in this. What I would do first is I would make a pretty picture. Realize I am not going to try to actually number these. That would be stupid. I don't believe in stupid. So we want to go to -3, 4. That looks like about -3, 4. I want to go to 8, 8. That looks somewhere about here. It's further out here and it's above here. I want to have -10, 0. So that's somewhere a little bit further and on the x-axis. And then we've got way out here in the middle of nowhere, equal to height to A, is 21, 4. I feel like I labeled these incorrectly. I'm going to flip these. These have different names now. This is A, this is B. I've now labeled this C, and I've now labeled this D, although I suppose it doesn't really matter. And I'm going to draw a pretty picture. Clearly, this is not to scale. I know. All right, so the first thing I'm looking at is what on earth are the slopes of each one of these lines. So if I look at the slope between A and B, if I look at AB and I look at the slope of AB, I am looking at the fact that this has increased by 4 and is increased. If you want to actually see the math, I suppose I could do that. 8 minus 4 over 8 plus 3. So now we have 4 over 11 here. We can find the slope of segment BC, which is 0 minus 8 over 10 minus 8, which is -8 over 2. We have slope CD. Wait, that wasn't BC. Yeah, it was BC. CD, which is 4 minus 0 over 21 minus 10, or 4 over 11. Ooh, hey, look, those look good. Cool, I notice AB is parallel to CD. And then if I look at the slope of DA, that is 4. Oh, goodness gracious, I just made a silly mistake. Don't be silly. One should always make sure to relabel things. That's a D. That's a C. Yeah, it wouldn't be the first time. Let me make sure that I've got these labeled correct here. This is definitely AB. This is BD. This one right here was CD. So AB to CD, those are parallel. The missing one is DA. So now that I've got that labeled correctly, we can do 4 minus 0 over -3 minus 10. DA. We look, this happens to be 4 over -13. That's BD, right? Yes. 8, 0 minus 8, 10 minus 8. Like that. Yes. Cool. Making sure that I've got these all set up. If I take a look at these 4 points, I notice that I only have a set of opposite sides that are parallel, and the only thing that allows opposite sides to be parallel is a trapezoid. Can't be a parallelogram because that has to have all equal parallel sides. Can't be a rectangle or rhombus or anything like that. These are definitely not perpendicular to each other. So I say trapezoid, and I am done. One thing I do want to point out, if you get a parallelogram, you do have to make sure that you don't have perpendiculars to check rectangle. And if I get a parallelogram, I really should check the side length. So parallelogram is the one you don't want to see come up first, because if you get a parallelogram and you don't have perpendicular sides, you're kind of screwed and have to check the side lengths. And you're still going to have to do that, but it's fairly easy to tell between rectangle and square when you do that. Cool. That's all I've got on these. I can do a couple more examples if people want to see them, but that's all I've got for quadrilaterals. Following up, this is areas and surface areas and volumes, where I'm just going to give you a whole bunch of formulas. And then we get into circles. I don't like circles, but we're going to do circles. There we go.